All right, hello everyone. Welcome to today's webinar on OpenRefine. I hope you all have OpenRefine ready to go, downloaded, and you can open it. And then also there's a link to a data file that we will use for hopefully at least just the half of our presentation today. And then we'll hopefully get into a little more advanced features of OpenRefine. So let's get started. As a note, this session is being recorded and you will receive a notification when the recording and the slides are available. So I'm Julie Goldman, Research Data Services Librarian at Countway Library, Harvard Medical School, and I offer a lot of these data management training classes. And I'm also available to the Harvard community for consultations, best practices for data management, creating a data management plan, or if you need to find data. And I just want to highlight the work of the Longwood Medical Area Research Data Management Working Group. We have a website full of resources and information about data management, and our group includes members from across the LMA from many areas such as the library, information technology, research computing, and our affiliate hospitals. So I suggest that you bookmark this website and reference it as you need. So let's review our learning objectives today. We'll explore how OpenRefine can help with common data cleaning challenges. You'll understand how OpenRefine can be used to standardize and clean data. And then hopefully you'll be able to use OpenRefine for reproducibility and consistency of your research projects. And of course, I will provide some links and resources for additional help and assistance. So let's first understand where in the research lifecycle we are today. So here's an example of the research process. And for this seminar, we are focusing on working with raw data and cleaning it for analysis. And a key step in preparing our data begins when the data is originally entered and stored in tables, because this, has an impact on the way we look at our data later on. However, much of our data that we work with is often very messy. So to prepare data for later analysis, it's important to have a nice, clean data set. And data cleaning is the process of detecting, diagnosing, and editing data. It involves maybe merging and enhancing data sets, correcting for missing data, standardizing and normalizing data entries, and verifying our data. So ideally, to accomplish these steps, we should have a tool to save, a lot of time and cleaning headaches. And it's important to know what you did to your data. Additionally, journals, granting agencies, and other institutions are now requiring some documentation of the steps you took when you work with your data. So with the tool we are going to talk about today, OpenRefine has many powerful features. It's really described as a powerful tool for working with messy data, but maybe an overall motivation for using OpenRefine is you can capture all the actions applied to your raw data and then share them with maybe your publication as this supplemental material. So if you're not familiar with OpenRefine, OpenRefine is an open source Java program that runs on your machine. It is a desktop application that uses your web browser as a graphical interface. So it is running on your computer, not in the cloud. So no internet connection is necessarily needed. And none of the data or the commands you enter in OpenRefine are sent to any remote server. OpenRefine can be used to standardize and clean data across your file. And it's really more powerful than Excel or in a spreadsheet program. OpenRefine does not modify your original data, which is great because we want to keep a nice clean file of our raw data. OpenRefine saves as you go, so you can return to the project at any time to pick up where you left off. Or you could export your data to a new file. And any operation that changes the data in OpenRefine can be easily reversed or undone. We'll look at that today. And as I have said, data cleaning steps often need repeating with multiple files. So OpenRefine is perfect for speeding up repetitive tasks by replaying previous actions on multiple data sets and saving the process you took. So some concepts such as clustering algorithms are quite complex, but OpenRefine makes it pretty easy to introduce them, use them, and show how they are useful. And just with OpenRefine, you can get an overview of your data set. OpenRefine can work with pretty large data sets, with over, 100,000 rows. It can resolve inconsistencies in a data set. It can help you split up data into more granular parts. You can enhance a data set with data from other sources, which hopefully we will look at later today. And you can save a data set or save a set, of data cleaning steps to again, apply them to other files. All right, so I hope you have downloaded OpenRefine and the example data set. If you have not, I'll throw these links quickly into the chat. So a very good question. This workshop will touch on some of the stuff we talked about in the June OpenRefine session. However, we will expand on those topics a little bit. So we will be using a similar tutorial, but hopefully we will move through that tutorial quickly and look at another example of how we can extend the data sets that we're working with. All right, so if we're ready to get started, I will switch over to my OpenRefine tab, and I'm going to locate that data set that I have downloaded. It should start with portal rodent, and it should be a CSV. So I'm going to open that into creating a project within OpenRefine, click next. And OpenRefine can import a variety of file types, including TSV, tab separated, comma separated, CSV, Excel, and even Google spreadsheets. And OpenRefine gives us a nice preview to show it that it understood what the file looks like. And I think this looks good. So we're going to get started and create our project in the upper right-hand corner. And I'll wait a second for my data to load. Great, so we're going to start with faceting and talk about faceting. And this is exploring data by applying multiple filters, basically. And facets are one of the most useful features of OpenRefine, and it can help you get an overview of the data in a project, as well as helping you bring in more consistency to your data. So one type of facet is called the text facet. This groups all the identical text values in a column and lists each value with the number of records in which it appears. So here we will use faceting to look at potential errors in data entry in our scientific name column. So go to our scientific name column, click the down arrow to facet, text facet, and we see on the left-hand side in our panel that we get a list of all the scientific names that are included in our data set, as well as the number of times it shows up within our data set. We can see we could hover over each name and we get an edit function. So if you quickly review what you see here, we see that there are some inconsistencies maybe with near identical names. And these are probably misspellings of the actual scientific name. So we could go in and edit each of these individually, but that's very time consuming. So later we'll look at clustering, which will be able to fix these inconsistencies much quicker. So let's look at how many years are represented in this census. So we're going to do a text facet on our year column. I'm going to click out of my scientific name text facet. And for the year column, we're also going to do a text facet. And this pulls all of the years that are included within our data set. And we can quickly sort this by count to see that the most observations were made in 1997 and the least amount of observations were made in 1977. So we can get this nice quick overview of what our data set contains. And as you notice, this is a text facet on a number. So we could also do a numerical facet on our year. But first, we would need to transform our year into a number. So we can easily do that by going to our year column, edit our cells, and common transforms. And there are a couple different transforms we can do, but we're going to change our year entries to a number. And we see that they have successfully transformed to a number. They're now green. And if we do another facet, this time a numeric facet, we actually get a nice histogram of the number of entries per year over on the left. You will notice that the date is shown as a number, not a date. If we were to transform this column to a date, OpenRefine assumes that all the entries are on January 1st of the year, but we know this is not the case because we have an actual month and day entry for each record. So we don't want to create our years as dates. All right, so let's talk about clustering and find out how we can account for maybe those misspellings and errors we saw previously. So clustering means finding groups of different values that might be alternative representations of the same thing. And clustering is a very powerful tool for cleaning data sets that may contain misspelled or mistyped entries. And there's a few, clustering algorithms that we'll look at. So I'm going to clear my left-hand menu. And in the scientific name column, we're going to focus on our scientific names. We need to create that text facet we created earlier. So facet, text facet. And then we have this nice cluster button. So I'm going to click this cluster button. And in the resulting pop-up window, you can change the method and the keying function. And we can try different combinations to see, what different mergers of values, are suggested. So I'm going to stick with the key collision method, and then I'm going to switch over to the metaphone keying function. And it should identify 3 clusters for us. And we can see that what it's doing, it's pulling very similarly entered names, and then providing what you want to combine these into across your data set. So usually this will be the name that shows up, the most. So I'm going to merge these 3 entries. And you can try, and I'm going to merge selected and recluster. And I see that these 2 algorithms, they haven't selected, found anything else. We could try different methods and keying functions, but we're not going to do that today. So I'm just going to close out of our clustering window. And we see that some of our entries, have the number of entries have gone down in our text facet. All right, so let's focus a little more on our scientific name column and split it into multiple columns. If the parts, within our column are separated by a common separator, such as, a comma, a space, or an underscore, we can use that separator to divide up the pieces into their own columns. So let's suppose we want to split the scientific name column into separate columns for the genus and the species. We can click the down arrow, go down to Edit Column, Split into several columns. And then in this pop-up window, we tell it how we want to split our columns. So we replace the comma with a space, and I want to keep this column. So I uncheck the Remove This Column, and I click OK. And I should get some new columns called Scientific Name 1, Scientific Name 2, 3, and 4. And notice that in some cases, the Scientific Name 1 and the Scientific Name 2 are empty. So the entries that have data in the Scientific Name 3 and the Scientific Name 4, but not the first two columns, had an extra space at the beginning of the entry. And leading white spaces are very difficult to notice when we're cleaning data manually, especially if you have a lot of records to look at. This is another advantage of using OpenRefine to clean our data. And we'll look at how to fix these leading and trailing white spaces in a later exercise. So I also want to maybe rename some of my columns. So if I come to the Scientific Name 2, the species column, I want to edit this column and maybe rename this column to species. I notice that I'm not able to do that. When I get a note, another column already is named species. And I see that the abbreviations column is called species. So if I wanted to have two columns named species, I would have to rename one of them. All right, so let's talk about the undo redo, because this is a really nice feature within OpenRefine. And it's common while exploring and cleaning, your data set to discover that you might have, made a change you really should have done, before something. And OpenRefine provides this undo redo operation in your left-hand panel. So we can click the undo redo, and all the changes we've made so far are listed here. So we can click on the step we want to go back to in this case, the previous step. So we now have our original 1 column for the scientific name. And notice that we can still click on the split column if we wanted to, toggle back and forth between these steps. So I'm actually going to go back to the state where the scientific names were clustered but not split. Because I want to get rid of those leading and trailing white spaces. All right, so to do that in our scientific name column, I can edit these cells. And one of our common transforms is to trim leading and trailing white space. So I'm going to click that, and our data refreshes, and then you can notice that the split step we did earlier has now disappeared from our undo redo pane. On the left is now replaced with this text transform that we did. So now we should be able to successfully split our scientific name column into several columns using our separator of a space. Again, going to keep our original scientific name column. And now when I perform this split of the column, we should only get 2 columns. And this is because removing the leading white spaces means that each entry in this column has exactly 1 space between the genus and the species name. So we have our nice two columns here. Okay, before moving on, I'm going to just go back to with our data in the one scientific name column. So again, use your undo redo to go back to where the scientific name column is not split. All right, and next we're going to focus on filtering. So there are many entries in our data table, and we can filter it to work on a subset of the data in the list for the next set of operations. So let's go back to our text facet that we have for our scientific name. And we want to do a text filter. So we can do that again from our drop-down arrow, a text filter on the scientific name. And in the box, we can start, typing something that we want to filter by. In this case, I'm going to type in BAI. And when it refreshes, we see that we have 48 matching rows of the original data set. So let's change our view at the top to 50 rows so that we could include all 48 entries into our view. And then we see within our scientific name facet that 2 names match our filtering criteria. And these are these 2 scientific names here. And we can also filter even further by including and excluding entries. So when we hover, over each of these entries, we see that we get another function to include each of these. So if I click the include for one of the scientific names, we see that now we are only looking at entries for this scientific name. These 46 matching rows, we have excluded the other entry. And we could then go back and include and then exclude the larger subset to look at, which species we want to. Great. So I'm going to make sure I'm looking at all 48 matching rows before moving on. We can also sort our data in a column by using our drop-down menu. And there are many different ways to sort our data. So if this is the first time, sorting this table, then the drop menu on each row will include a sort function, and you can select what you want to sort by. So let's sort the data by the plot number and try to figure out which years were observed, were recorded for plot 1 in our filter data set. So we want to sort our data by plot number. So we're going to come over to plot. We're going to click our sort. And we're going to sort by numbers since our plots are numbers. And we're going to look for the smallest first because we want to look for plot number 1. So if we sort by the plot number, we see that we now have at top, we have a sort by the plot happening. And we can easily see that for plot number 1, the years recorded were 1990 and 1995. We could also sort by multiple columns. The sort will really depend on the order in which you select columns to start. And we may need to, clear a sort before we continue with this. But let's look for trends in our data by month of collection across years. So first, maybe we want to sort our data by month. So we could come over to our month and column and click sort, again by numbers, smallest first. And then we see a new option pop up, which is sort by this column alone. Because remember, we're also sorting by plot here. So if we wanted to sort by only month, we would click that, and this creates a new sort of our data set. We can review this by coming up to our sort at the top, and we see that we're only sorting by month. Again, we could also do this by year or by month. But say we wanted to sort by year, month, and day in some order. So we could actually sort by all three. So let's try that out. So let's add another sort. First, we'll sort by the year column. Again, by numbers, smallest first. We're going to start by just doing the year first. So we click the sort by this column alone. So now we're sorting by our years. Then we want to sort by month. So we add a sort, again by numbers, smallest first. But this time I'm not going to click the sort by this column alone, so that I'm first sorting by year and then by month. And then we can come in and also sort by our days. Again, number smallest first. And we don't see much happening with the refresh, but we can see that we're now sorting by year first, then our month, and then our day. Great. So OpenRefine, provides a way to sort and filter our data without, affecting our raw data. We are, working on a new creation of our data set. All right, so let's clear our sorts. So we can easily do that by coming up to the top and removing our sort. And now we're not sorting our data in any way. All right, so when this table is imported into OpenRefine, all columns are treated as having text values. And we saw that earlier when we dealt with the year column and transforming it into a number. And we can transform columns into other data types using that common transforms feature. So let's remove all of the text facets we have going on right now. Go back to our original view. And we want to transform cells in this record ID column to numbers. I'm just going to hold on a second while my data refreshes. And I might be stuck. We'll see. I appear to be stuck, so let me see if I can open another OpenRefine window. All right, well, I will use this one. This was going to be for a little later, but we'll use this window and see if I can go back to see. Luckily, been working on this earlier, so I can go back and open up a project. So you can see how you can go back to previous projects that you had been working on. All right, so we appear to be in a very similar place that we were before. So as I said, we were going to transform cells in the record ID column to numbers, and this we did earlier. So if we come over to the record ID and we come down to edit cells, common transforms to number, again, we see that it changes to this right adjusted green text. And only observations that include only numbers, so 0 to 9, can be transformed to numbers. If you were to apply this number transform to a column that doesn't meet this criteria, and then click the undo redo tab, you will see a step that starts with text transform on 0 cells. And that means that the data in the column was not transformed. But we successfully have transformed our record ID into numbers. And so sometimes there are non-number values or blanks in a column which may represent errors, again, in data entry, and we want to find them. So let's do that with a numeric facet. So for a column you transformed to numbers, edit 1 or 2 cells, replacing the numbers with text or blank. And use the pull-down menu to apply a numeric facet to the column you edited. So let's look at that. So we can come into our record ID, maybe add, an ABC to the end. We'll apply, and then again, you can see that we'll do this to the next row as well. You can see that it is no longer really a number because it is now justified different and it's black. So if we were to come down and do a facet, numeric facet here, notice that there are several check boxes in this facet. We have numeric, non-numeric, blank, and error. And below these are some counts of number of cells in each category. And we should see that we have mostly numeric, but then we have the 2 non-numeric entries that we created. So we can experiment with checking what happens with these subsets. All right, and we want to go back and reverse these edits. So let's go back to where we did text transform on our record ID, and then remove our facet. So we can see that we now have nice, clean record ID numbers. All right, so as you conduct your data cleaning and your preliminary analysis, OpenRefine saves every change that you've made to the data set. And these changes are saved in a format known as JSON. And you can export this JSON script and apply it to other data files. If you had 20 files to clean and they all have the same type of errors, such as species, name, misspellings, leading white spaces, and all the files have the same column names, you could save a JSON script, open a new file to clean in OpenRefine, paste in that script, and run it. And this gives you, a quick way to clean all of your related data. So in our undo redo, we could click extract and select the steps that we want to apply to other data sets by clicking, the uncheck boxes. We could, copy the code right from this right-hand panel and paste it into a text editor, like Notepad or TextEdit, and make sure it's saved. We can save it as a text file. So I'm not going to show you how to do that there, but you can come in and copy this and paste it into, a text program to do that. The last thing I'll show you before we look at something a little more advanced is exporting and saving our data from OpenRefine. So in OpenRefine, you can save or export your project, and this means you're saving the data and all the information about the cleaning and the data transformation steps you've done. Once you've saved a project, you can open it up again and, just where you stopped before. So by default, OpenRefine is saving your project as you go, as I've mentioned. If you close OpenRefine and open it up again, you should see a list of your projects, and you can click on any one of them to open up again. But we can also export our project, and this is helpful, for instance, if you wanted to send your raw data and your cleaning steps to a collaborator, or share this information, as I mentioned earlier, as a supplement to a publication. So we can click export in the upper right-hand corner, export our project, and we see that a tar.gz file will download to our default download directory. There it is, showing it down here at the bottom for me. And the tar.gz extension tells you that this is a compressed file, which means that this file contains multiple files. So we could open this and explore those contents. But basically, when you open this, you should see a history folder, which contains 3 zip files. And each of these files itself contains a change.txt file. And these change files are the records of each individual transformation that you did to your data. And then a data.zip file. And this file includes a data.txt file, which is a copy of your raw data. And there may be some other ones as well. We could also go back to our project and just export our cleaned data rather than the entire project. So if we go back to export, we have a couple of options where we can export our data to. So if we wanted to export it to another, cleaned up CSV file, we could do that as well. Remember that from our lesson on, when we talk about spreadsheets and data organization, widely supported non-proprietary file formats like TSV or CSV improves the ability of yourself and others to use your data. Great, so we have about 20 minutes to look at something a little more exciting. So I'm going to push this back over as I was set up earlier for this before. I hope you can see now I have OpenRefine on the left, and I have this name validation tutorial on the right. And this is going to kind of build on the concept of looking at species names and how we can validate our species names across two data sets. All right, so I'm actually going to now open a new project. And I'm going to create a new project using, sorry, I'll go back to create a new project using a URL. Sorry, I clicked through that pretty quickly, but creating a new project, you should see a couple of options. And one of them is through a web URL. So I'm going to grab that URL from this, these people created this great tutorial. I'm going to copy in this URL right here. I will also paste it into the chat if you are following along and also want to create a new project via this URL. And this is another way where you can get data into OpenRefine. So I'm going to click next with this URL, and we can see it's downloading and I'm compressing our data. And we see that right now we're looking at a kind of line-based, text file view. And we need to make sure that we delineate this correctly. So we see that it is using commas. So if we select the CSV / TSV, make sure it's commas. We can see that it now nicely parses out our data into our columns. So I'm going to name our project as it suggests in our lesson plan as ITIS, and we're going to create this project. Give it a minute. All right, I am going to close out of my other OpenRefine project since it looks like we're going on edge. All right, so we see we have successfully loaded our data. We're going to locate this taxon name complete column. Let's rename that so it's a little easier to work with. So to rename a column, again, it's edit column, rename this column. We're going to call it canonical name. Okay, so we successfully renamed our column. So I'm actually going to stop right here and review some of our takeaways. So yes, data is messy, but you can do something about it. OpenRefine is a great tool for working with our messy data. We saw how OpenRefine gives you a quick overview of many empty values your data set may contain, and how often a particular value shows up. OpenRefine can help us split data into more granular parts and solve recurrent issues such as duplicates and misspelling inconsistencies. And then, you shouldn't hesitate to experiment when cleaning your data because OpenRefine is, saving as you go. You're performing these steps on, a copy of your data set, not the actual raw data. And so you can trace back all your steps and undo, redo if you need. And there are lots of different tutorials available to you. We went through most of the cleaning with OpenRefine for ecologist data today. There's also a library carpentry OpenRefine, and there's lots of OpenRefine documentation available to you. So next week, we don't have a seminar, but there's lots of Open Access Week programming happening. So I encourage you to check all the events happening next week across Harvard University. Open Access Week is also international, so there may be events happening closer to home for wherever you're calling in from. And then at the end of the month, we'll have a session on data horror stories, looking at, things gone wrong with data management and how we can avoid and correct them. So thank you for joining today. Please fill out the survey at the link provided on the slide. Thanks everyone for joining. It was a small group. If you have any questions, feel free to just call out and ask them. If I do get that reconciliation lesson working. I'm happy to share it with you. Looks like one of their links isn't live anymore, so that kind of breaks your breaks the ability to use open lesson resources that other people have created. So that's a data management lesson within itself for having persistent URLs, persistent files that you're providing to work with. Thank you, everyone. I don't see any questions. Feel free to reach out if you do. And I will end today's webinar there. Take care. Bye-bye.